Hello everybody, I will start my today another coding practice. So in this video, I will solve this question. Guess the word. Okay. In this question, I'm giving an array of unique string words where words I is 6 places long. Okay, so each word is 6 places long. One word of the words are chosen as a secret word. Okay. You were also given the helper object master. You may call master guess word, where word is a 6 word letter long string and it must be from words. So I see. Yeah. I will call the master dot guess with any of the word in the words list. And negative the master returns -1 if word is not from the words. Hmm? Word -1 if word is not from words or an integer represents the number of extra matches, value and position, or you guess to the secret word. Hmm? There is a parameter allowed guesses for each test case, where allowed guesses is the maximum number of times you can call master to guess words. Yeah. And for each test case, you should call master to guess with the secret word without exceeding the maximum number of allowed guesses. Mm. You will get either you took too many guesses or you didn't find the secret word if you called master guess more than allowed guesses times, or if you did not call master guess with the secret words, or you guessed the secret word correctly if you called master guess with the secret word without in the number of calls that master guess less than or equal to allowed guesses. Okay. The test cases are generated so that you can guess the secret words with a reasonable strategy other than using the brute force method. Okay, I understood. So no, I have really understood. So I'm given the no, I'm only given the list of words and master. And I see, I understood. So I will try to find the secret word. And um any of the word in the words is the secret word. And I have to call the master dot guess with the secret word. But if I do brute force for, I will try to master the guess call with each word one by one, and finally I will reach the secret word. But that approach doesn't work. I have to choose the secret word smartly. And when the master guess is called with the word, it returns some response, like -1 or 6 or 3 to 4 in this example one, which is yeah, how many words matches the secret word. Um, Also, yeah, in the correct position. Okay. So in this example case, the secret is actually ACCKZZ. So yeah, when master the guess is called with say CCBAZZ, because the second C, first C at index 1 and that's Z as index 4 and 5 are correct. So there's 3 matches. So I get the response 3. So from this number 3 can be used to guess the secret word in a smart way. And when I take a look at the EIOWZZ, this returns true. So because comparing ACCKZZ and EIOWZZ, I can find the last two Z to be matched, so 2 is returned. And for ABCKZZ and ABCCZZ, there is only one, different word, which is K versus C. So the remaining number of characters, which is 4, is returned. Oh, actually, it's the second character and third character, not the second character and fourth character are not correct. So 6 minus 2 is 4 is returned. Okay, good. I understood. Mhm. I see. Okay, so let me think. Yeah, obviously the brute force approach is as written in, even though it as written that it doesn't work. Ask the word one by one until I must find the secret word. Okay. So let me think with this example. I think one approach I've just come up with is that for each word, I will have the pre-calculated map which represents like the match count to possible words. Yeah. So for example, in the case of ACCKZZ, first I compare with CCBAZZ and I find that C is the correct position and yep, ZZ. So there should be 3 match count. So if I call with this and I get the answer 3, it means that CCBAZZ is, kind of candidate of the word. Yeah. And I built it for each count to word list like this. Yeah. I don't know. So what I would do is first I call with this character, and I call the match master.guess, and I guess the match count. And the possible words, secret words is now limited. And next I will call with either of these characters. Yeah. Then I get some response. And from that, I assume which character is the one. Yeah. Okay. I think how it works. So number of words is 1,100. But actually, so building this match counter words hash map, I have to take a look at 100 times 100 combination pair. So it should be 10,000. And for each pair, the word of the length is 6. So in total, it takes 10K, 60K times of character check operation. It isn't so big enough, too big. So I think I can do it. Okay. Let me think if there is any other way I can, do it more efficiently. So, mm, no, I don't know. Maybe this is the best approach, I think. So let me, quickly. I initiate this hash map, then I will initiate. No, so then for each call, what should I do? So okay, let me do the word indexes. Yeah, so in this way, candidate word indexes should be start with set. Yeah, so 0 to n as well. Then for each call, I filter candidate word index. I will call from candidate word index and filter candidate word indexes, and also remove this one. Also, yep. But I think this one should maybe included again after this candidate word index is called again. I mean, in the future by the different word. So what I want to do is I'd like to avoid the same word calling again and again. So, oh no, it doesn't happen because this candidate word indexes is always reduced. Yeah. Okay, so this is what I mean by that. So for each call, I call from and then index it and remove this one. From the result, yep. Filter out words in candidate if not included. Okay. So this is how it works. Okay, so let me assume the time complexity should be, I can't say correctly because it totally depends on the result. But let's say the words are reduced one by one. So in that case, the time compression should be O of n calls. And also for building the map, this should be n times 6. And also what it takes. Oh, also I need the filter out process. So this should take n times because there are n result words and I have to take a look at each of no, I mean I have up to n candidate word indexes and I have to check each of them if it should still remain or not. This should take n times n. So I think this should be n squared time. Wait, what am I saying? N is the number of words. Okay, so I mean, just a brute force. Just a brute force takes n time until the end. But if I do the smart approach, actually it takes n squared time in the worst case. But there's higher possibility that I can find the word before, you know, always read before n squared time because I can filter the words one by one, and I don't have to check each of them. Okay, for space complexity, it should be, count word to words should be n squared space complexity. Yeah, because each word has n. Okay, so I mean, Albert checks each pair of n words, and for each, it increment one key optionally and one value in each any of the list. Yeah, so it should be n squared. Okay, yep, that's it. And also for candidate words, this takes n. So this takes n squared. Okay, that being said, let me does the implementation. Build count to words. So I built it. I will implement this helper function later. Okay. And I initiate the candidate word. Yep, in this way. Okay. Okay. And the next thing I will do is I will make the code. Hmm? How many? Yep. And while answer is not the correct one, I keep the iteration and I guess the word. So I pick one word from candidates. Then I will try to call master.guess with this. Yeah. Then this is the answer. Wait. Okay, let me change my implementation. Okay. And if this is no like this, it's the end. Also, if answer is either you took many guess or yeah, in these cases also I should finish. So let me hmm? You guessed an either Okay. So these are two words which should be termination word answers. In this case, I break. Otherwise, I keep going. So this is a matched count. So I can filter the words with this answer. In this way. So I filter this candidate. Yeah, so this is it. Okay, one thing I need to do is I found a mistake. So where was it? Possible words much. I see. So I think much to words. Okay, so this should be, here in line 9, this should be set of word indexes. Otherwise, in line 47, if word in possible words, this takes longer time. Okay, so let me work on the build match to words implementation. So for each pair of the indexes, I will check the count. Oh, okay. So in this way, I get the match count. So once I get the match count, I should register it to the, you know, match to words, hash map. Okay. Wait, what kind of data structure I wanted? Build match count set words. No, I think I actually don't have to build this first. I think after, you know, guessing the word with the candidate, I guess the answer. So I will take a look at each word in the candidate and confirm if the match count is correctly calculated. If so, the candidate can still remain there. But if not, the candidate should be popped out. Okay, so let me change my implementation. So I remove this and I will return the helper function, which returns the match count for given two words. Okay, so now here, maybe here. Okay. So in this way, now candidate should be updated in this way. Okay. Mhm. Okay, let me say it in this way. So I hope I have the filter method in Python, but I probably there isn't. Yep. Okay. So anyway, so this is how it works, I think. Oh, and I will implement the much count method. Okay. Good. So let me work through my code. So I initiate the match to words, but I don't need it. Okay, great. So I initiate the candidate with all the index in the word list, and I keep going the iteration. So in line 39, I pick one guess word from the candidate. Then I, you know, call master to guess with that guess word. Then I will guess the answer. If answer is one of the termination answers, I break here. And in okay, line 45, where's that? Oh. I will take a look at each word in line 46, and I will confirm the guess word. I mean, match count between guessed word and the current word is the exact answer. If this is true, that word is still the candidate. So I append it to the word satisfying answer. Yeah. Then finally, I will update candidate with word satisfying answer array. Good. Okay, so let me run my code. Wait, what should I call with? Master. Ah, I see. So this is actually just the index. Okay, so wait a minute. So I should call it in this way. Then in line 45, where's satisfy? This is where the index is. And also for candidate, let me rename it to candidate indexes. Mm-hmm. Okay, so for this line 46, this should be one index. Okay. So let me work through again. So in line 45, I guess the guess word index, and I or must guess with the word. Then I get the answer. And in line 46, I will take a look at each candidate indexes, and I confirm that match count of guess word and word index. This should be like this. Okay, okay, I will confirm each the two pair words has the match count, which is equal to answer. In that case, word indexes satisfying answer should have word index. Good, I think this is good. I run my code again. so I'm missing something. What's the interface of master guess? No, this should be, yeah, master variable. Oh, so candidate. Wait, candidate index. I see. So this means that I couldn't find any answer. Yeah. Mm. Let me print how it has been reduced. So firstly, when I come here, it should have this. But when I called with ACCKZZ, oh, definitely I think I made the correct call. I guess the answer. So I should terminate. But it's not terminated. Why is it? Hmm? Wait, so what does this master guess return? I see. So I can completely forget this, but I should just take a look at this and this. If -1, if word is not from words or an integer variable, the number that matches. Okay. So here, instead of in line 43, if answer is equal to length, 6, then that's the end. Okay. Otherwise, I have to keep going. Good. Okay. And I will assert that answer is not -1 because I make the master guess call with only with the word in the words list. Hmm? Why is it? Let me take a look. What was A B C C Z Z? If this is in the list. Oh no, sorry. This shouldn't be -1. Good. Okay. I submit my code and I got the wrong answer. What? Okay. So I actually couldn't, filter the answer in a smart way. I called too many times. Okay. Okay, so let me think. So every time I guess the answer, I think I filter the result. So let me try with this test example. Firstly, the candidate was all the indexes. But now it becomes this. And then this and this. Gradually, it becoming shorter and shorter. It seems like many characters have the quite similar, strings maybe. Yeah. Wait, so hmm, so this time I call maybe more than 10 times. Yeah. One more, I have to check 44, 1 and 45. Hmm. Either I took too many guesses or I didn't find the secret. Probably I couldn't find the secret first. In the end, sorry. So let me think. I have to filter them more smartly, I think. Hmm. Okay. So hmm. Yeah, the time is not the problem actually. The number of calls is the problem. I have to, filter the answers in a more smart way. Wait, but I think in this case, I called only from the candidate. But there isn't any such a rules that I shouldn't call it from the, non, non-candidate word. So maybe it is possible that if I pick the word which is not in the candidate list anymore, but it helps me to filter, narrow down the possible candidate more compared with something I picked from the candidate list. Yeah. And yeah. Hmm. Okay. So, hmm. Hmm. Wait a minute. Hmm. Okay, so I have to find the answer in 10 times. Hmm. What was wrong with my way? Or is there any way I can, you know, filter from some information I was missing? Wait, so one approach I've just come up with is, for example, if I guess with the word, in this case, this means that the possible words should be, this or, yeah, in this way, maybe I can filter possible ones. Yeah, so I will get something like this. Mm. So I will take a look at each, template. Then how many template can I make from one code? In the worst case, 63. This should be, 20. Oh, not so much. Not so many. Okay. Yeah. Mm. Wait, so did I really make use of the result answer in possible way? So mm, yeah. So I can filter the regex in 20 patterns. So I think, but if I next I find that the words should follow this, then obviously, wait, if I find the next, it should be like this, or maybe I find this, it should be like this. No, I mean, if this should be like this from the next answer, if I find this, obviously candidates which are filtered, yeah, I mean, the regex cannot be, it's quite limited. So this could still have some match with this and this, but it cannot be like this. Yeah. And there's a conflict in B and Z. But it is not filtered yet so far. But when I get this, the words in the template of CCB is filtered out. So I actually don't have to think of it. Yeah. Mm. So there are 100 words, and I'm allowed to call only 10 times. So is there any information missing? That's what I'm wondering. Maybe I'm missing something. Okay. So if this answer, CCCB AC answer is 3, the regex is limited. Yeah. And when, you know, I mean, I get up to 60, regex from each answer. Yeah. Mm. Mm. Okay, so I stopped the video and I read the answers. Yeah, from many people. And basically, what I found is that my strategy is good, but there is only one, there is something I'm missing. So it is in line 55. How I choose the guess word? To choose the guess word, it is written in some solutions that I should choose the word which is similar to so many words. So let's say I have like A, B, C, D, A, B, C, E, A, B, C, F, and X, Y, Z, Z. Then I should not choose X, Y, Z, Z as the next guess word, but I should choose either of A, B, C, A, or A, B, C, B, or A, B, C, D, which are similar, which are so many similar words, kind of similar words. So, you know, this is a bit, um, annoying thing, and I actually haven't completely understood why that's a good why I can say that's a good strategy. But let me first re-implement it first, and let me think later. So so I should say most common word, or I should say word with highest similarity. Yeah. Okay. So now I calculate the word index with highest similarity. So the first thing I would do is, for example, let's assume I have A, B, C, D, and A, B, C, A, B, C, B, A, B, C, D, and X, Y, X, 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 X. In this case, firstly, I count the, for here, there are 3 A's and 1 X. And here, there are 3 B's and 1x. So I count each of them first. Then when I take a look at ABCA, I find that there are three, characters. I mean, three strings which have A in this position. So I underscore 3. And next, when I take a look at B, I can find that from here, there are three words which has B in this position. So I increment I mean, the score is incremented by 3. So in that way, I calculate the similarity score. Yeah. So in that way, I can find the kind of most average or highest similarity word. So yeah. Okay, so let me implement it in this way. So here, the first element should be the chair to frequency hash map. So I build this chair to frequency hash map for the number of elements. Okay, so firstly, I initiate this chair frequency. So next, I will take a look at each word index. And for each word, oh wait, yep. No, this should be like this because there's 6 characters always in each word. Okay. Yeah. So this is how it works. Okay. Then I guess the chair frequency. Let me print it out. Okay, so in this case, so I can see any of one, word indexes. I ignore the error. I can see it here. So when this and this, okay, so I will take a look at all the characters and see the chair frequency. So the first character, it should be A twice and C once, E once, yes. For the second character, it should be C twice, C twice, yes. I once, B once. Okay, seems good. So let me continue. So now I will find the max. Yeah, so So for each word index, I guess the word as in this way, and I will check for each char. So for char in from the char index, I guess a true frequency. This is the position. So in this way, I guess the score. Yeah, I have this current score, and after getting the total score, if it exceeds, then I update the max score word index. Oh, I mean, I update the max score first, and also max score index should be current index. Yeah. Then I return the max score word index. Yep. Okay. Let me execute my code. Oh no, let me walk through this method. So firstly, I initiate the child frequency list. This is the list of counter. Yeah, this is good. And in line 89, I try to find the best word with highest similarity. So in line 89 and in line 90, yeah, I initiate max score and max score word index. I put 0 for now because it is guaranteed that at least one word is, in the word indexes. Then in line 91, I will take a look at each word. Yep. Then I calculate the current score. Yes, in this way. And with that current score, I update the max score variable and also max score word index variable. Good. Okay, run my code. Accepted. So it seems like how many times was it called? Only 5 times. So yeah, much smaller times. Okay. Now let me submit my code. Good, accepted. Yeah. I actually have no idea why this works. Maybe statistically, or maybe for mathematical reason. Maybe I will dive deeper into this after I mean finishing this video. But anyway, let me quickly wrap up. So in this video, I solved the question, guess the word. And in this question, I'm given the word list, words, and each word is 6 letters long. And I try to guess the secret word in this word list. And the operation I'm allowed to do is ask the master if specific word is the secret or not. Or I should say, and master answers with the match count. Yeah. So that's a yeah, that being said, I'd like to, guess the secret words as with least master calls as possible. Yeah. So okay. The approach I took was I will ask a word to the master, and from the answer, the possible answer, I mean, secret words is limited. So I will keep the words which still can be the secret words I mean, only such words remains a candidate. Otherwise, for other words, they are removed from the candidate. Yeah. So in that way, I've reduced the number of candidates one by one. I mean, or in every um, guess call, then I find the secret word. But I still had to do a kind of optimization. It was that when I choose, word to be guessed from the candidate words, I had to choose the word which has the highest similarity in the candidate words. So I define the similarity score as the number of, I mean, chairs which number of chairs in the word candidate words which are at the same position as the word I'm thinking. So it's a kind of score, similarity score for each word. Then I choose the word with the highest similarity, and that optimizes my solution, and mine was accepted in the end. Okay, now I finish my today's practice with this. Thank you so much. Bye.